Now, continuing on with our work in Bernoulli Trials, we're going to have a look at question 22 on page 211. So we're still dealing with Bernoulli Trials, we're still dealing with independent events, and we're running multiple experiments, and we have success or failure conditions. So we can set up the question to either be a success or a failure. Now, in question 22, a card is drawn at random from a normal deck of playing cards and then replaced. So, key language here, normal deck of playing cards. How many cards are we dealing with? We're dealing with 52. We have to know that by heart. What other key piece of language is there? And then replaced. So, and then replaced means we take a card out of the deck, we look at it, and we put it back in the deck. So that means that when we take out a card, it doesn't have any effect on the next card that we're going to take out, because we're replacing them back into the deck each time. So that means we have independent events, so we can use Bernoulli Trials. So that's our two key pieces of language in the first line. Now, question part 1. What is the probability that the card drawn is a picture card? This is another very important part of exam technique. If they ask you a question that seems very simple, if you can see a Bernoulli trial coming up ahead of you, don't assume that the question is more complicated than it actually is. Take the question at face value. What is the probability that the card drawn is a picture card? We've been asked about one card being taken out of a deck. What's the probability that it's a picture card? We know how to do a question like that. It's just the probability of getting a picture card. So we're not worried about it being more complicated. We're just going to take it at face value. So what's the probability of getting a picture card when we take a card out of a normal card deck? Well, we have 3 cards in each suit are picture cards. We're going to have a jack, a queen, and a king are our 3 picture cards. So a jack, a queen, and a king are our 3 picture cards. You must know that by heart. You must know that they are our picture cards. So we have 3 picture cards out of each suit, and we have 4 suits, so we're going to have 12 in total. 12 picture cards out of a total of 52 playing cards, and that simplifies down to 3 out of 13. I recommend you write it this way. Technically, the way I'm getting to this is I have 3 picture cards out of a suit. If I know that the suit has 13 cards, technically I could write this down. This is what they're going to be looking for in the marking scheme, so it is better to write it out in this form and then simplify. So that's part 1 done. That is all that there is to part 1. So if you get a probability question on the exams, we don't have to assume that any question that gets more complicated later on isn't simple at the start. So if you see something and you think you know how to get the probability of a single picture card coming out of a deck of cards, just do that. Now, part 2. A card is drawn repeatedly and then replaced, independent events, until the 3rd picture card is drawn. Find the probability that the 3rd picture card is drawn on the 13th attempt. Now, there's a danger in our Bernoulli trials that we might get confused here, and we might, I'm going to write it down, so we have 13 trials, we want to have 3 successes. Our probability of success is going to be getting a picture card. Probability of success is picture card, so OP is going to be 3 out of 13. Probability of failure is going to be not that, so not getting a picture card, which is going to be 10 out of 13. Now, what's the problem with this? This is the setup for getting 3 picture cards when we run the experiment 13 times, when we take 13 cards out of the deck and replace them. But that's not what the question asked. It said find the probability that the 3rd picture card is drawn on the 13th attempt. So we must get a picture card on the 13th attempt. So how would we break that down then? We don't have this situation here then. What we've got is we have to get 2 picture cards in the first 12 attempts. In the first 12 trials, we have to get 2 picture cards, and we can get them anywhere. And we must get a picture card on the 13th attempt. Now, it doesn't matter that it's the 13th attempt because they're all independent of each other. So we must get probability of 2 picture cards in the first 12 trials, and then we must get a picture card on the next attempt. So that's what we're after, and this is the only thing that I really wanted to show you in question 22, that we have our picture card, 2 picture cards in the first 12 trials, and then we must get a picture card on the 13th trial. So we do these out separately and multiply our answers, because and in independent events means multiply. So let's set this one up here. So we're going to deal with this part first. We have 12 trials. We want to have 2 successes. Our probability of success is probability of getting a picture card is 3 out of 13. Probability of failure, which is Q, is going to be 10 out of 13. That's the setup here, and we know that the probability of getting a picture card we already worked out in part 1 is going to be 3 out of 13. So we now know everything we need. Let's write this out. We're going to have 12, choose 2. We must have 2 successes out of 12 trials, multiplied by probability of success to the power of our number of successes, multiplied by probability of failure to the power of our number of failures, which is going to be 10 failures. If we are running the trial 12 times and we want to have 2 successes, we should have 10 failures. And we are going to multiply that by the probability of getting a picture card on our 13th go, on our 13th trial. So we must get 2 picture cards in the first 12 trials and get a picture card. Now, when we put that into our calculator, we get some fairly unpleasant decimals. Doesn't stay as a nice fraction for me anyway. 2, 5, 4, 9, 6 by 3 over 13. When I put that in the calculator, I got 0.0588836, and that roughly gives me 0.06, rounding to 2 decimal places, which would be the standard in most of these questions. Because this is small, you could actually round to 3 or 4 if you wanted to, but the standard is round to 2 decimal places in a question, unless it specifically asks you to do one thing or another in the exam. Now, that is all we need for now, and that is the main complication that comes into Bernoulli Trials. If it asks you about having a particular success on a particular run of the experiment, this is how we're going to deal with it. And that's the skills that we need for right now.